In this video, we're going to learn how to graph exponential functions. On the left, I put some facts about exponential functions that I'll refer to throughout the lesson. Now, the first thing you want to notice at the very bottom left is that exponential functions are either going to grow exponentially from left to right, meaning going upwards rapidly, or they're going to decay, meaning they'll start at a high value, and then from left to right, they'll start to approach zero and flatten out. Now, these are the very basic forms of an exponential function, which we're going to look at a, the growth factor, to the x power. So, we're first going to try to graph each of these functions, determine its domain, range, and the horizontal asymptote that forms, which normally is just at y equals 0, which is the x-axis. But sometimes if we start to put on transformations, that can shift somewhere else. So let's look at f of x is equal to 2 to the x power first. Now when graphing, there's only a few basic points you need to get. First is if you ever plug in 0, if there are no transformations on the function, it's just a to the x. When you plug in 0, you'll get 1. That makes sense because if I plug in 2 to the 0 power, that's 1. The other points are if you plug in 1, you'll get the growth factor, like 2 to the first. That makes sense. That should just be 2. And if I plug in -1, I'll get the reciprocal of that power, since negatives will usually bring a number to the denominator. So instead of plotting 2 for -1, I would plot the reciprocal of 2, which is 1/2. Now, if you go for any more points, if this is not enough to see what your graph is going to look like, if I plug in 2, I would square the growth factor. So 2 squared would be 4. And if I plug in -2, I would square the reciprocal. So the square of 1/2 would be 1/4. Now what you're starting to see is starting to flat out along the x-axis. That just means that my horizontal asymptote, for whenever a is bigger than 1, just approaches 0 as x approaches -infinity, meaning as x becomes really negative, it just gets closer to 0. So I'll put a horizontal asymptote there. And connecting the dots, this is what my function will look like. Kind of curving and then growing very steadily and more. In fact, if you were to start to zoom out on this graph, it would almost look like it's going vertically straight up. Now let's identify the domain of this function. For all exponential functions, the domain should be all real numbers. The range is usually on one side of the horizontal asymptote, which in this case I'm above it. So the range should be y is greater than 0, as x becomes very large. Another way to put that as well is 0 to infinity. And another way to write all real numbers is -infinity to infinity. Now, lastly, the horizontal asymptote. It's going to be y equals 0, because it starts to flatten out at that value. So that's what I'll put as my horizontal asymptote. Now let's graph a number whenever a is less than 1, but still positive. What happens there? Well, still, if I plug in 0 for x, 1/3 to the 0 power is still 1. And I plug in 1, 1/3 to the 1 power is 1/3. So I'm still getting the growth factor when I plug in 1. And when I plug in -1, I'll plot the reciprocal of the growth factor. So the reciprocal of 1/3 is 3/1. So at -1, it goes up to 3. Now I can continue to move to the right. So I could square my growth factor, which is 1/9. Still positive, but very small. And I could square the reciprocal, which is 9. So at -2, I go up to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when I connect the dots, you'll see that it's a little bit steeper than it was before. I'm noticing a small mistake I made. I counted -3 instead of -2. So I'm just going to fix that real quick. So at -2, it goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can even see it's definitely even steeper than I initially thought as well. And then it still flattens out to 0. But in this case, since a is less than 1, when it flattens out to 0, it's for positive x values, as x goes to infinity instead. But the horizontal asymptote would still be at y equals 0. So my domain is all real numbers, -infinity to infinity. My range is still above the horizontal asymptote. So it's still 0 to infinity. Y is greater than 0. And then my horizontal asymptote is y equals 0 still. Now we're going to plot a few functions that have transformations on them. So you need to identify what the transformations are so you can graph them. The first thing you want to notice is that whenever I go to graph this -x, that's a reflection in the y-axis. So y equals 2 to the -x is a reflection across y-axis. So every point that would be on one side of your graph, it will be reflected. So at 2, 4, I now have a point at -2, 4. Which I'm putting in pencil because I still have to incorporate that -3 later. Then the point at 1, 2 is now at -1, 2. The point at the y-intercept still stays at the same spot because you can't reflect the point on the y-axis across it. Then the point at -1, 1/2 will now be at 1, 1/2. And then point at -2, 1/4 will now be at +2, 1/4. So very lightly, because I'm not done yet, here's what my function looks like so far, which I'm going to erase away after I incorporate the next transformation, which now, incorporating the -3, the -3, is a vertical translation down 3. So every point, this will now lead to my final function, is every point goes down 1, 2, 3 from where it was. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So now my function is starting to flatten out at a different spot at y equals -3. So when I go to graph this, it flattens out along that line now instead of y equals 0. Then climbs upwards. And that original function I had drawn in the intermediate stage, I'm going to erase away because it's not part of my final answer. So that is the graph of this function, which when reading out its domain, it's still all real numbers. So -infinity to infinity. The range is now, instead of being greater than 0, it's greater than -3. So from -3 to infinity. You don't include -3 or 0 because this function can't actually equal 0. When you raise a number to a power, whether it's a positive or negative power, it can either get really big or really close to 0, small, but never exactly 0. And the last thing to get is this horizontal asymptote, which has now been shifted down 3 to y equals -3. Let's look at the next example. First, we're going to apply that 4 in front of the 1/3 to the x. I'll take care of the +2 in the exponent later. I'm going to take care of one thing at a time. This is a vertical stretch by a factor of 4. So all that means is every point is going to be multiplied by 4 in the y vertically. So the y value is multiplied by 4. So this one's at -2, 9. It will be at -2, 36, which I can't plot. The one here at -1, 3 will now be at 3 times 4, which is 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it goes off the grid as well. So at some point way up here, and the point that's at 0, 1 will now be at 1 times 3, so 0, 3. And then the points at 1/3 will now be at 1/3 times 4, which would be 4/3, so 1/4. And the one at 1/9 times 4 will be at 4/9, so at 2 4/9, which is just below half. And I'll still be flattening out along my x-axis, but here when I go increase in height, I never quite reach the next x value since I know it crosses at 12 above the grid. And then I flatten out. Now, the next transformation is just +2 by the exponents. So 4 times 1/3 to the x plus 2. When you add 2 into the exponent or near the x, you're going to actually shift horizontally. So you'll have a horizontal translation. But now instead of going right 2, like you would think, it's actually left 2. Kind of the opposite. So every point gets shifted left 2. So 1, 2 to the left. 1, 2 to the left, and 1, 2 to the left. Now I'll graph this one out. Again, it never reaches the next x value, it just gets very high up. And it still flattens out at 0, because I didn't go up and down. Now I'll erase away the intermediate graph. And then I'll write out its domain, range, and horizontal asymptote. Domain is still all real numbers, so -infinity to infinity. Its range is still 0 to infinity, because it didn't go up, shift up or down, so this asymptote stays at y equals 0. So the range should go from 0 to infinity. Now let's put HA for short, but the horizontal asymptote is y equals 0 again. And that is how you graph exponential functions.